make my recommendation on what points to use. You guys noticed the 1/3, right? I would plug in values that are divisible by 3 or 0, right? Because 0 is a really good number to plug in the first place. So let's make our chart. I want 3 values, okay? And you'll be required to have 3 values on the assessment, okay? So our first section of the chart, wow, what's happening? Hold on. There we go. Our first section of the chart are going to be my x values. Then I'm going to have my f of x values. And then I'm going to put them in as a coordinate, x comma f of x. Is this still scented? Yeah. Okay. So, what x values should I use? I definitely want to use 0. David? 3 is one of them. And -3, okay? These are the values I would recommend you use because then you're not going to have to deal with fractions because you're dividing by 3 during the problem. Let's plug in -3. Who wants to plug in -3 for me? Karen? Mm-hmm. Mm-hmm. Uh-huh. It'd be 9. -1/3 times 9. Very good.
And then you have to multiply, so it'd be -9/3.
Mm-hmm.
Simplifies to -3.
Which is -3. Very good.
-3 plus 2 is -1, so it'd be -3 comma -1.
-3 comma -1 is my first point. Very good, Karen. -3, -1. Let's go ahead and put that on our graph. -3, -1. All right, let's plug in 0. Who can walk me through 0? Matthew?
Alright, so you plug it in, which gives you -1/3, parentheses 0, and to the power of 2,
Mm-hmm.
plus 2.
Yep.
And then, you divide it, which it becomes 0.
Yep, so it's going to be 0. Bless you.
Yeah.
0 squared.
Yeah, 0 squared.
What's 0 squared? What's 0 squared? That's for the whole class. What's 0 squared? 0 times 0 is 1?
0.
Wait, what's 0 times 0?
0.
What's 0 times anything? 0. So 0 squared is 0, and then 0 times 1/3 is still 0. So we have 0 plus 2. What's 0 plus 2? 2. So my next point is at 0, comma 2. Okay? Matthew, where's 0, comma 2?
On the 2.
On which axis?
1.
On the y-axis. Very good. On the 2, on the y-axis. And then let's plug in 3. David, can you do 3 for me, please?
We got f of 3 and it equals -1/3 parentheses 3 squared plus 2.
Mm-hmm.
They give 3 squared to give you 9.
Mm-hmm.
And then you do -1/3 out of 9. Give you -9/3. And then you divide by 3. It'll give you a -3
Mm-hmm.
plus 2.
Yep.
Give you 1.
Not 1.
-1.
There you go. -1. All right. What's your point? 3, comma -1. And when I put that point on there, 3, comma -1, how is my parabola going to look?
Like a triangle.
Like a triangle? This is what my parabola looks like? How should I draw my parabola? It's going to be curved. Which way is it facing?
Down.
Down. How did I know before I started this problem that this parabola was going to be facing down? Matthew?
Because the 1/3 had a negative.
Excellent. This negative indicated that my parabola was going to be facing down. Would you guys agree, isn't it a bit wider than what we're used to with our standard parabola? Why did it get wider? David? What?
+2.
Not the +2. That's a different transformation. It is a transformation, though. You are correct. But what transformation? Why did it shrink? Because of the 1/3. Remember, when that a value is smaller than 1, right? When its absolute value is smaller than 1, it's going to shrink your graph. It's going to make it wider, okay? It's going to make it more wide, right? More bowl-shaped. And then lastly, why is it shifted 2 units up? David, that's because of the +2, okay? So as soon as you're done graphing your chart, go back and be like, okay, what transformations actually happened here? And do they match what I graphed on my graph, okay? Go ahead, Caden. What questions do we have on this example?
For the test, are we gonna have to write all the transformations?
Yes. Would you like me to write them out for this one? Okay. So the negative was what? What did that negative sign do? Not a shrink. Yeah, it made it flip upside down, right? What do we call that? What transformation? It's a reflection. Very good. So there was a reflection. Okay. Now we move on to the 1/3. What was the 1/3 doing? I think Austin said that one.
Shrinking.
It was a shrink. Very good, Mia. And I always say by what factor? So it's a shrink by what? By 1/3, right? Don't include the negative. The negative is a separate transformation. Remember, the negative was our reflection. You got that? The shrink was by 1/3, okay? And what was the last transformation, Colin? Trans what? Translation, aka a shift, right? You can use either of those words. It's a shift where, Colin? Up to. Why up to? Is +2, okay? Because it's +2.
Why is it not to the right too?
Why is it not to the right too? It's a vertical reflection. Remember, Mia,
Negative though?
what?
Isn't it negative?
The 2? No, the 2 is a positive. The 2 is being added.
Oh, I'm sorry.
If it was negative though, it would be down. For left or right, Mia, that would have to be x + 2 squared. It would have to be inside the parentheses. We won't see that, Mia, until one of the later chapters, or sections, excuse me, okay? Good questions. Any other questions on the warm-up? Okay, let's pull out our homework from yesterday. Let's go over that. We are now adding in what term? BX. So do you guys remember when we were factoring, I was like, you're going to have an A, you're going to have a B, you're going to have a C? We left out B this entire time. 8.3 involves that B value. Now, before we only talked about vertical like shifts, correct? It could only move up or down. When you add in that B value, you end up shifting your graph to the left or to the right, okay? Now, it is not a direct shift. So if your B value is 2, that does not mean that you shift to the right 2, okay? It's related by this ratio, -b over 2a. And the most important part of today's lesson is this guy right here. You definitely want to circle him, okay? Your axis of symmetry is going to be x equals -b over 2a, where b is that value that's next to your x term, and a is that value that's next to your x squared term, okay? So your a value comes from here, your b value comes from here. All right, now some things I want to point out to you. When that a value was positive, right, what did our parabola look like? Was it a U or was it an N?
U.
It was a U, okay? Write that in there. When our a value became negative, when it was less than 0, was it a U or was it an N? It was an N, okay? It opened down, okay? Remember, that still applies even with that random b value being added in there. Now our y-intercept is our c value. So whatever that value at the end is, that c value at the end of your quadratic, you're going to put 0, c is going to be a point on your graph, okay? That is going to be your y-intercept. The x-coordinate of your vertex, aka your axis of symmetry, is this golden ratio, negative b over 2a. And I want you to circle both of them in there. It's super, super important. That's probably the most important thing of all of today's lesson, is that negative b over 2a. Okay, so the first part of today's lesson is we're just going to use that ratio, and we're going to find both the axis of symmetry and the vertex of these functions without graphing them. So before, right, I would give you a parabola and be like, where's the axis of symmetry? Where's the vertex? And you'd find the vertex by looking at the graph, correct? What if you're not given a graph, right? So what we're going to use is we're going to use that ratio. So we're going to write AOS for axis of symmetry. And our ratio is going to be x equals negative b over 2a. Yes.
To unlock the curve type.
Okay, take out a paper and pencil. All right, so
Is that 2A?
that is 2a, correct. Now, we have to go back. Addison, what's up?
Can I use one?
Yes, you may. Set a timer, please. What are my a, b, and c values for this function? A is 2. B is positive 8.
C is negative 1.
C is negative 1. So now plug in your b and your a. This is going to be x equals negative what? 8 over 2 times 2. Pause. Does everyone see what I did here?
Yes.
Talk to me if you don't. You got it?
I got lost up on my curve.
What happened, David? What's confusing you? Talk to me.
Oh, I got it.
We got it?
Yeah.
Okay. Now it just becomes a matter of solving this fraction. What is 2 times 2?
4.
Okay, so what's negative 8 divided by 4?
4 over negative 2.
What?
I mean negative 2.
It's negative 2. So guess what I just found? The axis of symmetry is x equals negative 2
So this lesson is finding the axis of symmetry.
without a graph. Now, hold on. There were two things being asked for us. It wanted the axis of symmetry and the vertex. So, remember, does our vertex always lie on the axis of symmetry?
No.
Does our vertex always lie on the axis of symmetry? Yes, because the axis of symmetry is the vertical line that goes through your vertex, correct? Now, when you have the axis of symmetry, we're going to use that and plug it into our original function, and that will give us the y-coordinate of our vertex. So watch, we're going to take this negative 2, and we're going to plug it in for x in our original function. So we're going to say f of negative 2 equals 2 times what? Negative 2 squared plus 8 times negative 2 minus 1.
Got you. There's a lot going on.
There is a lot going on, but it gets really simple once we start to use our order of operations. What do I do first here, peeps? Okay, parentheses, but is there anything to solve inside the parentheses?
Exponent.
No, there's nothing inside the parentheses, so then we move on to exponents. Very good. What exponent do I evaluate? Negative 2 squared. What's negative 2 squared? So it's going to be 2 times 4 plus 8 times negative 2 minus 1.
Wait, where'd you get the first two? Oh, 2 times.
Yeah, I got the first 2, Mia, from up here. I'm just plugging into my original function.
Now we do
Okay? You guys with me? All right, what comes next? 2 times 4, which is 8. What else?
plus 8 times negative 2.
What is 8 times negative 2?
Negative 16.
Negative 16, and then I still have a minus 1.
So we have a
What do I do now?
16 plus 8.
Combine the like terms. Very good. What's 8 minus 16?
Negative 8.
And what's negative 8 minus 1?
Negative 9.
So guess what? Who thinks they know both the x and the y values of my coordinate? Matthew?
Negative 9 is y.
You're right, yeah.
And then negative 2 is x.
Thank you. Negative 2, comma, negative 9. Look at it again. This is my AOS. Axis of symmetry. This is my vertex. Where'd the negative 9 come from? Mia, that negative 9 came from when I plugged in negative 2 for my x value in my function. What?
I look at it.
You don't get it? So, were you with me when I was plugging in the negative 2?
Yeah.
When I simplified this right-hand side, Mia, it just turned out to be negative 9.
Oh.
So then I knew that my negative 9 was my y value in my final answer for my vertex.
Okay.
Does that make more sense? Are you sure? Yeah. Okay. What other questions do we have, guys? All right. We're going to do B now. Should we freak out because one of our terms is missing?
Yes.
Yes?
Yes.
Oh, sure. Go for it. Let's see how you do on the test when you freak out. Okay. So let's identify our A, B, and our C. Alfonso, what's my A value? What's my B value? What's my C value? No. Can I write C equals nothing, Alfonso? What do I do? It's 0. Very good. Okay. Whenever a term is missing, the coefficient there or the number is 0. Okay. So my C value is equal to 0. Now I'm going to go ahead and get started. My axis of symmetry. Who has the formula memorized? Karen?
Is it negative b over 2a?
You're so good. Okay, negative b over 2a. Someone else plug these values in and tell me what I get.
Wait, I have a question.
Yeah, Salucci.
When you plug in the negative 2 to the b, does it stay negative? Or does it
Ah,
cancel out?
good question. Let's walk through this one. So it's going to be negative, and you agree, Michael, we're plugging in a negative 2? So isn't it going to be negative 2? Ah, it becomes positive 2. Very good. But we're plugging in negative 2 over 2 times 3. So, negative 2, Michael already said that's going to be positive 2 over, what's 2 times 3, peeps? 6. Guys, a common mistake. Does this give me 3?
No.
What does it give me?
1 over 3?
1 over 3. Okay? Again, another moment for learning. Are we going to freak out because our axis of symmetry is a fraction? No. X equals 1 over 3. It makes you nervous? That's okay. All right, so we're good on axis of symmetry. We're halfway done. Now we also have to find what? The vertex, okay? Your y value of your vertex. So we're going to take this 1/3 and plug it back in like David said. So it's going to be f of 1/3 equals 3 times 1/3 squared minus 2 times 1/3.
Uh-oh, no, we gotta do first though.
What do we do first, David?
We do the exponent.
Very good.
1/3
So
squared.
evaluate that exponent. F of 1/3
1 over 9.
equals 3 times 1 over 9. Very good.
I'm on fire. Let me
Minus 2 times 1/3. Now that we've evaluated our exponents, can I go ahead and multiply?
Yeah.
Sure. What's 3 times 1 over 9? It's going to be 3 over 9, right?
Yes, yes.
Minus, what's 2 times 1 over 3? 2 over 3. Do you guys agree?
Yes.
Can we subtract these the way that they are? Why not?
They don't have like denominators.
They don't have a common denominator. Can you simplify one of the fractions, though?
Yes, we can.
Caden? 3/9 simplifies to what? You're so good. 1 over 3 minus 2 over 3. Now can we subtract these
Yes, we
fractions?
can, mister.
Bingo. They've got a common denominator of 3. What's 1 minus 2? It's not 1. It's negative 1 over 3. All right, someone put it all together for me and tell me what my vertex is. Caden? Negative 1 over 3, comma, negative 1 over 3? No.
Can I get you right?
Thank you, Salucci. It's a positive 1/3 and then a negative 1/3. Talk to me.
What you want me to tell you?
Talk to me.
Alright, I'm talking to you.
It's not bad? Okay, let's see how not bad it is. Try C on the next page on your own. No fraction, just a standard axis of symmetry and a vertex. Alec, what's up? So, vertex should have been -3, -4. Okay? I need someone to walk me through getting the axis of symmetry first. David, go for it.
I want you to make the
You want to do the vertex? Salucci, can you do axis of symmetry for me, please?
Okay, so to start, I plugged in the -b over 2a, and I got -6 over 2 parentheses x. Then I simplified it to -6
Wait.
over 2x.
2x.
Up to 1, I plugged in.
Oh, yes. The a value is 1. Correct. Okay.
And then I got -6 over 2, 2 comma 1, and I simplified that to -3.
Mm-hmm.
And that was my x value, so I plugged that back in, and I got -3 to the power of 2.
Hold on. David's going to take over from here. So g of -3 equals?
-3 to the second
Mm-hmm.
plus 6 times -3 plus 5.
Okay. What'd you do first?
I did the, he gave me 9 plus 6 times -3 plus 5. But then he gave me 9 minus 18 plus 5.
Good. 9 minus 18 plus 5. Okay.
Then I subtracted 9 minus 18 give you -9.
Okay. Plus 5.
5 give you -4.
Yeah.
Now you put all together, you get -3, comma, -4.
Guys, clap it up for Salucci and David. All right. So,
Any questions?
why is this helpful? Well, you remember all those charts we used to have to do? In 8.3, we can now graph quadratic functions without using a chart. I'm going to do one example with you guys, okay? And then we're going to call it for today, okay? So bear with me for one more example. What was that?
What happened to the test results?
Oh. All right. All right. So let's take a look at example 2, letter A. We have to identify the axis of symmetry of the vertex, graph it, and then find the domain and the range, okay? So let's start. We're going to do the exact same thing. Let's look at this function. Let's identify the axis of symmetry first, and then the vertex. Matthew?
Alright, so to start off, you plug in -6. Wait, no, that is. Oh, wait, sorry. Then you put the, what is it called? The line, the dot?
A fraction bar?
Yeah.
Okay.
2
2.
times 3.
Okay. Matthew, I agree with you, but Matthew is forgetting one small but super important detail. Because if you forget this, you're going to get the whole question wrong, and it's only because you start off the problem on the wrong foot. What did Matthew forget?
Oh, I don't want to.
Natalie?
The B is negative.
The B needs to have another negative symbol. Matthew, did you remember that?
Yeah.
It's negative B over 2A. Okay? All right, keep going.
Wait. Doesn't it make it positive?
It does make it positive. So it's positive 6 over.
6.
What is 6 divided by 6?
1.
1. So what's my axis of symmetry, Matthew?
1.
Very good. All right, so Matthew found the axis of symmetry. I need someone else to take over to find the vertex.
The
Andrea, thank you.
So you plug in 1 for x, and then it should be the same for each one.
Mm-hmm.
So it should be 3, and then, okay, yeah.
Okay, so we plugged in 1. What do I get?
And then you get 3, 6, and then 5. And you add those.
Wait, did I miss something?
Yeah.
Is that a negative 6 there? Okay. That should be a negative 6. Good catch. All right, keep going.
And then you should get -3 plus 5, because it's -6.
Correct. Okay, negative 3 plus 5.
And then you get
2. Very good. What'd you say?
f of 1 equals
Good. So what's my vertex? 1, 2. Very good, Andrea. All right, so we have my axis of symmetry, my vertex. Hey, listen up. We have not touched on this yet. I told you that your y-intercept for a parabola in this form was 0, comma, your c value. So I know another point on my graph is 0, comma, 5.
You have 2 points.
0, comma, c. Please highlight that, guys. That we have not touched on yet. We need that point in order to make our full parabola, okay? All right, let's go ahead. Let's put each of our sections on our graph. Let's put the axis of symmetry of x equals 1 on my graph. Not yet. Okay, let me finish. How would I put an axis of symmetry of x equals 1 on my graph?
Put the thing on 1.
I put what on 1?
The dot.
A dot on 1? Which one? What's the axis of symmetry?
X equals 1.
Where did I get x equals 1? That was my axis of symmetry. Okay?
Put the dot on 1, but on x.
Oh, on the x one. So there's a dot here. The axis of symmetry is not a dot, guys. What is it?
It's a line.
It's not even just a line. It's a dotted line. It must be vertical or horizontal? Vertical. And it must go through x equals 1 for this case. Where was my vertex, peeps? What did Andreas solve for? 1, 2. So that tells me how high up on my axis of symmetry my vertex goes. And then what was the last point that I had? 0, 5. Where's 0, 5?
Facing down. Right there. And it's going down.
It is not facing down. Let's think about it. Look at your A value. Is my A value positive or negative? So that means my graph should be up. Check it out. You're going to start at the vertex and draw a curve going up. Why is the axis of symmetry so important? Think about the wording. Axis of symmetry. Shouldn't it be symmetrical?
Yeah.
So do you agree that that point was 1 unit to the left of my axis of symmetry?
1 unit to right.
So there should also be a point 1 unit to the right. So there should also be a point right here, and we're going to draw another part of our parabola facing that way. Wait, why what?
Why do you have to give 1 on the other side?
Well, remember, your axis of symmetry, right, Mia? It cuts your parabola directly in half so that it's symmetrical on both sides. So if there's a point right here, Mia, that's 1 unit to the left of your axis of symmetry, you have to flip that point over to the other side. So now I know there's also a point on the right-hand side. Okay? Did we use a single chart for graphing this one?
No.
No. So we're going to be able to do both methods, okay? If you're a chart person and you love charts, feel free to just use a chart and be able to figure out the vertex and the axis of symmetry, okay? But these problems do become a little bit more complicated, and you may not be able to create the best chart in the world, okay? All right, turn these in. Shoot. Domain is what?
ARN.
All real numbers.
And the domain is y less than 2.
Y is not less than or equal to 2.
Greater than 2.
Greater than or equal to 2, okay? Because look, Addison, at 2, it's all the values above 2. What?
You need to unlock this, please.
Oh, I need to unlock you?